So here we go. I'll be using the example on Reid and Sanders to explain probabilistic time estimates. Please remember that this chapter is also available on Moodle. Now, you will recall that in our last Skype lesson, we discussed the critical path method, which makes use of deterministic time estimates. But we also said that given that projects are unique and one-time, then we can't be certain about the duration of activities. This means that for your own projects, PERT, which I'll be explaining in this video, is more appropriate. To start off, when we use probabilistic time estimates, we need to establish 3 durations for each activity: the optimistic time, the most likely time, and the pessimistic time. And denoted by O, this is denoted by M, and this is denoted by P, respectively. For convenience, we will list these time estimates in a table called the Probabilistic Time Estimates table. So in the book, that's example 16.4. You will notice that the time estimates are listed here. So we've got optimistic O, most likely M, and pessimistic P. But there's an additional column which says expected time. How do we calculate expected time? Well, this is a very simple weighted average that adds the optimistic time plus 4 times the most likely time plus the pessimistic time. So basically, more weight is given to the most likely time. Now, if we were to add these, it's like there's a weight of 1 on optimistic time, a weight of 4 on most likely, and the weight of 1 on pessimistic time. So if you count that, 1 plus 4 is 5, 5 plus 1 is 6, which means it's like we have 6 different numbers, which we don't, but it's like we do. It's like we have 6 different numbers. So if we apply this very simple formula to each and every one of these, we get our expected time. For example, here, if we add up 2 plus 4 times 4, which is 16, so 16 plus 2 is 18. 18 plus 6, which is 24, and we divide 24 by 6, because that is exactly what our expected time formula says. The answer is 4. Now, please plug in this formula into Excel and don't do it manually. So, the same formula exactly will be repeated for every other row. So here we have 3 plus 4 times 7 plus 10 divided by 6, and that answer would be 6.83. As you can see, some of the expected times have been rounded off to 2 decimal places, and that's very likely, and it will probably happen to you as well. So, what's the next step? You need to prepare a very simple network diagram with all the expected time activities. So this is a diagram using circular nodes, and we're just listing the expected time here. So A had an expected time of 4, B had an expected time of 6.83, and that's listed here. C had an expected time of 3.17, and we're just presenting it in network diagram format using simple circular nodes. We also identify the connected paths. So, as we discussed in our last lesson, we need to identify these connected paths because we need to find the critical path. And the critical path is the path that needs to be monitored most closely. Why? Because if any activity on the critical path is delayed, then the whole project will be delayed. How do we know which is the critical path? Well, basically the critical path is also the path that takes longest to complete. So if we were to add up all the durations for these paths, we'll very easily find out which is the critical path. So for the first path, what I would do is add A, B, D, E, G, H, J, K, which is here. A, B, D, E, G, H, J, K. So for that path, we can add 4 plus 6.83 plus 6.83 plus 16 plus 2 plus 3 plus 4 plus 2. And we document that in a table, which is our path through network table. The same paths are listed here, and we calculate the expected completion time in weeks for each path. So, if we take a look at this, the longest path seems to be path 2, and that is our critical path, in fact, because it's the longest completion time. It's slightly longer than path 1. Moving on, this is here where I have to refer you to the other book for a presentation issue. It's a cosmetic issue if you want. So rather than presenting information in this way, it would be way better to present information similar to this. So this is something that you're more likely to find in project management reports. So I'm shifting on to the same network diagram. I created this network diagram using Google Drawings, but you can use any software to create it. And what I've done is I converted the circular nodes into a box. So before we just had a circular node with A4. Now we have a box for each of the same circular nodes. I also added the start and the finish, which I highly recommend because otherwise you might get confused, especially if you start off with 2 tasks. You wouldn't know how to start it off. So the box, each of those boxes, top left-hand corner, I've got the activity. Bottom left, I've got the duration, the expected times. Then I've got the early start date, earliest finish date, latest start, and latest finish. What I'll be doing first is I'm starting what is called as a forward pass. But I'll show you how to do the forward pass in our next video.